Welcome to this video. In this video, we will do some more advanced visualizations using the Altair package. First, we're going to import the package. Once again, if you are on a recent version, you don't need to enable the renders to be notebook. Second, we're going to visualize a slightly larger data set. Altair, for performance purposes, limits the number of observations to be 5,000. If you want to disable this option, you need to specifically disable maximum rows. Otherwise, any attempt to visualize a data frame, which is more than 5,000 observations, will just throw an error. In this exercise, we will use a data set about the COVID-19 pandemic spread in multiple countries over the world as of the time of recording the video, which is March 27, 2020. It will be interesting to rerun this notebook once this pandemic is over to kind of take a look, understand and examine the different ways the disease spread across different countries. Let's read the CSV and take a look at what the data is about. So this data has 69 columns. Now the first 4 columns are the province or state, country or region, latitude and longitude of these countries. In some countries, we only have aggregate country level data. In other countries, for instance, such as in China, we have a province, we kind of have more fine grained data. The data is broken by multiple provinces. So that's why in the countries that we don't have provinces, we have a null value in the province and state. The remaining columns are basically the dates in which the number of cases were reported, and the value itself is the number of cases reported on that day. For instance, if you take at Afghanistan, we have 22 cases reported on the 17th of March, so on and so forth. The very first step we need to do is to convert this data to a long format, to a tidy data frame, because Altair understands each column to be a variable. And those columns, it's kind of like an unstacked data frame. Although it's useful if you want to see it as a table, this is basically the value of the date, right? The date ranges from January 22nd to March 26th. So we need to condense this data to a long format where we have only date as a column and the number of observations inside the value of that observation. The number of cases, the value of that observation in the column. So the very first step is a data transformation step. Okay, so how do we do it? Well, first we need to unstack our data. That's what we need to do. But before we unstack the data, we need to before we stack the data, we need to differentiate between the date and the remaining columns we have in the data frame. So what I'm going to do before doing anything, I'm going to split the data into 2 data frames. The first data frame, I'm going to call it part 1, is basically the first 4 columns, all rows, first 4 columns from the original data. So that's basically the country information, province and country, longitude and latitude. The second one is the opposite. I'm going to take the last 4, the remaining columns in the data frame to be part 2. So I'm going to pick everything from 4 onwards. And that's going to be part 2. This is basically all the dates we have from January 22nd to the end. The next step, what I'm going to do, I'm going to stack part 2. And the reason I want to stack it is that I want these to be columns, the dates to be columns. So if I stack part 2, I'm going to get a multi-level index in which the first level is basically the number of observation and the second level is basically the column. We need this first level because this is how we're going to combine the 2 data sets after all. Once I stack this data frame, what I'm going to do, I'm going to reset index. When I reset index, I've got 3 columns. That's the original index. The second one is the date. And the third one is the value, the number of cases. So let's call this thing df. And I'm going just to create meaningful columns name index, date, and cases. And I need to reset the index. Well, I don't need to, but it's useful to reset the index to be the original index so that I can join the 2 data frames on the index, rather than I join on a column and an index from the part 1 data frame. So let's see what we've got here. We've got a new data frame in which the index is the original index. So you can see that each one of these observations, for instance, Afghanistan, I've got multiple observations now because each date is its own observation. And the last step I need to do is to join these 2 data frames together. So what I'm going to do, I'm going to join part 1 with df. And of course, because I made the index here to be the original index, I can just do a join. And I recreate the data frame as Altair needs it to be in a long format. So if you take a look at the first at the shape of the data, which is here, you can see that we've got 69 columns. This one has 6 columns, but it has 16,000 observation, which is 248 repeated for 69 minus 4, because those are the number of columns representing dates. So if I do this one, 69 minus 4, that's what I get here. And that's a long format data frame, a tidy format. This operation, which is converting from wide format to a long format, is a very common operation. And indeed, there is a built-in function in pandas called melt that allows us to do the same thing. So we have converted the data. I'm going just to redo the conversion using the melt function. The melt function basically takes you call it on the original data frame, and you supply 2 parameters. What we call the ID variables, and those are the variables that determines the observation in a long format. So in our case, those are the state, region, latitude, and longitude. So they're basically part 1 columns. And then the wide formatted columns, those are called the value variables. And in our case, it's the columns of part 2. That basically does the same conversion for us. Creates a data frame that has the same shape, and we probably need to do some renaming to rename the variable to be date and value to be cases. Alright, so we're going to use the data frame COVID in this case. We have successfully converted it. Let's take a look at number 2. Now, the second conversion that we need to do is to basically aggregate at the country level data. Now, again, the problem in this data set is that some countries have data at the province or the state level, so we need to calculate the total per country. So for instance, if you take a look at data pertain to China, for instance, if I do country region equal to China in this case, so that's a mask. I'm going just to apply the mask to the data frame. You can see that I've got different provinces, states in China. So what I need to do here to treat China as one country, because otherwise I've got scattered observation per each one of these provinces, is to aggregate per country, region, and also date. So I want the total number of cases in each country in each date. So what I'm going to do next is to convert this, calculate the total number of cases in each one of these groups. So I'm going to group by country, region, and date. I'm only interested in cases here. So in this particular exercise, we're not going to worry about latitude and longitude. Those are useful if you want to create some cartographic visualizations, which is possible in Altair, but we're not covering it. We're going to take cases, and we're going to take the sum of the cases. So that's the sum of the cases in each country, each date. Again, this is a series with a multi-index, so the next step is to reset the index. That basically give us the data frame. Let's call this one, it's a country level data frame. The last thing I need to do, which is not a must here, but if you take a look at the data types of this data frame, date is represented as a string. I'm going just to convert it to a date object. It's not needed here, but it's nice because it also kind of opens up opportunities to create some date transformations, such as looking at things, over days, weeks, months, so on and so forth. So what I'm going to do now, I'm going to take date, and I'm going to convert it to a date time object. So I'm going to use the function toDateTime, and that basically will parse these string and convert them to date time objects. And I'm going to override date because I don't need it anymore. So that's the data frame I'm going to use in order to create the visualizations. Next, using line mark, I'm going to create a timeline of cases per country. So I'm going to create the chart object here using country, and I'm going to mark line. Now it's a timeline, so my X will be the date, and my Y will be the cases. We need different lines, a line per country, so I'm going to make color to be equal to country/region. Alright, let's take a look at this error message. We forgot to use the encode function. Okay, so I need to mark line to set the graphical marks and then call encode. Alright, so here we go. Here's the figure, the chart we get. We get a different line chart. I'm going actually to put tooltip here. Tooltip is useful, so to see what, kind of locate what each line, I'm going to put tooltip here. Okay, so those are the different growth chart, the propagation of this disease in these countries over time. That's the China's line. That's the, I believe, Italy. The tooltip is not very sensitive. That's Italy. And this one, I believe, is the United States. Yes. Now again, there are so many countries here, so that's probably why the figure is super busy here, because there are so many countries. Let's only look at the top 5 countries in terms of total number of cases, which I believe are China, the US, Italy, I'm not sure, maybe France, maybe the UK. We need to kind of crunch these numbers. So first we need to calculate, or the numbers, the countries that have, the top 5 cases in aggregate terms. That observation. What I'm going to do now, I'm going to take a look at my date. And let's focus on the last date. So I'm going to make sure that the dates will be sorted in this data frame, but just in case, I'm going to sort values, and I'm going to take the last one. That's basically the last date we have in this data frame. So this is going to be iLock here, and that's the last date. So last date is this one, and what I'm going to do next, I'm going just to create a mask and filter only observations of the last date. Next, I'm going to sort values, number of cases. And in this case, ascending, because I'm interested in the countries, the top cases, ascending is false. So the top 5 countries are the US, China, Italy, Spain, and then Germany. Of course, I'm interested in the country names. So what I'm going to do here, it says the top 5 countries. So I'm going to pull country region here. And I'm going to take, this is too much for one line. So I'm going to take the top 5 observations. So I'm going to take the head of that, and I can convert it to a list if I wish to list. And those are the top 5 countries. Okay. So next, I want to filter my data from the original data frame so that I only have top 5 country data. The next step is to create a new data frame, top 5 data, and I'm going to start by taking well, let's start by creating the mask. What's my mask here? I'm going to say that country region is one of these top 5. So I can either apply a function that tests whether this one is in this top 5. So I can do apply lambda x in top 5. That will be my mask, and I can use this mask here to mask my data. I get only data about these 5 countries. Alternatively, there is a built-in function in pandas. So instead of applying this, I can do country region is in top 5. That's basically the same. So I can go either route here. It doesn't make a difference. Okay, so let's call this one top 5 data. And I'm going to assign this to a new data frame. Next, I'm going now to create my chart. So that's exactly the same chart specification, except that I'm going to use top 5 data instead of data. Actually, I'm going to use the same specification here, so I don't type it. The only difference is that instead of country, it's top 5 data. So that basically will create a chart in which I can only see the top 5 countries and their trajectories over time. The last one is asking us to create a similar chart for China, but plotting each province on a separate line. So here we need to go back to the original data here, the COVID data, because the country data is aggregated. So what I'm going to do here, I'm going to filter this data so I only look at China. I'm going to create my mask here. And I'm going to use the mask to filter the China-related observations in multiple provinces. Let's call this data frame China data. And my next step is to create the chart using China data. Again, that's the same specification, except that instead of color being country region, I want color to be the province. So I'm going to use China data. Date cases will not change. I want the color to be the country, not instead of the country region, it has to be the province or state. So I'm actually going to copy paste it from here. Let's put province and state here, province and state by using T here, and this problem is resolved. And you can see here that now it understands it, it renders it as a well-formatted date here.